How's everybody doing today? We're in section 8.6 today, natural logarithms. So what you'll be able to do at the end of the day, you'll be able to evaluate natural logarithms and solve natural logarithms. So what we've been dealing with prior to now is log and base 10, typically. All right. And we've used some other bases along the way, but basically we've been using log base 10. So now we're going to basically use log base e. Okay, that's all natural log is log of base e. So in other words, if this is your picture here, if picture 1 is the exponential, y equals e to the x. Okay, so if x is 0, y is 1. If x is 1, y is e. So 2.718, etc., so forth and so on. That's just a normal exponential curve. And again, e is a number, it's not a variable. And its inverse exists as, again, we just can change the x and y coordinates and get this picture here. And same thing here, 1 and 2.71. It's right there-ish. Okay? So this is y equals ln of x. All right. So basically, this is more practice from section 5 because all the things that we did in section 5 we're now going to do in section 6, but using natural log instead of log base e. Okay. So the notation, so this problem really isn't any different. So right is a single natural log. So natural log, ln is natural log of 12 squared minus natural log 9. So natural log, so division becomes multiplication, or excuse me, subtraction becomes division. And I have one statement, natural log, 12 squared is 144 over 9, and that is 16. So I get natural log 16. Okay? We wrote it as a single log. We squished it together, basically. Okay? And again, to emphasize, this is log base e of 16. That's what that number represents. E to the what, 2.718 to the what is 16. Okay? And it should be between, 2 and 3. And that's going to be in your calculator. Okay? We'll do this quick check together in class. All right? Okay, let's solve. Okay, so just like before, this is problem 2. This is an x in the logarithm statement. So I say, okay, I'm going to have to go ln. First thing I'm going to do is I'm going to write the e in, just like I was writing the 10 in. Okay, 2x minus 4. Bring that 3 out here by the power rule. Can do that. That's perfectly legal. And then I can say, okay, I can divide here. Okay. 6 divided by 3 is 2. You can do that, right? And then, so basically, we get e squared, right? Swoosh across here. 2x minus 4 equals e squared. Okay, e again is a number 2.71 squared. And shoot, that number turns out to be, so let's just continue right here. Take this thing down here. So 2x equals e squared plus 4. Okay, 11.4. And x equals 11.4 divided by 2. 5.69. Okay. And again, we can work on we'll work on those quick checks in class. So again, your problem solving is still the same, and this is a nice one because again, you don't want to necessarily start by cubing in there because that's going to make a big mess. So you take that out, divide by 2, and then life isn't so bad. Okay, and again, what is the ln of e? ln of e is just, again, log, so let's go, ln is the same as log base e, okay, of e. So basically, e to the what, right? So e to the x equals e to the first, so x equals 1. So basically, anytime you get ln of e, log base e of e, you get 1. And this is a beautiful thing because you're going to see ln of e a lot in equations, and then you're going to just wipe it out, and life is going to be good. Okay? All right. So now let's solve this guy. All right. So again, what do I have? I have an x in the exponent. Okay. So okay. So that means I gotta go ahead and isolate this guy first. So subtract 1.2. 4e to the 3x equals 12.8. Divide by 4. E to the 3x equals 3.2. Now I'm ready to take the log of both sides. But now, since I'm with e, I'm going to take the natural log of both sides. Let me move this guy over a bit. Same thing, but that's the same thing we did in section 5, right? That's the exact same thing. All right, just the only difference is instead of log, log, for base 10, I'm using ln for natural log. And again, I want to keep emphasizing this. ln is log base e, okay? Log base e. So now that allows me by my power rule to say 3x equals ln of e, ln of 3.2 over here. Yay! Look at this. This is a 1, right? So multiply. So basically, 3x times 1 doesn't change anything. So x equals natural log of 3.2, which you can get in your calculator, and divide by 3. Okay? That turns out to be 0.3888. Okay? Quick check we'll go ahead and save for class. And now we're going to solve a money problem like this, okay? Compounded continuously. So continuously. There we go. Sorry about that. So continuously means I'm going to be using my formula to start before I do anything else. A equals principal e to the rate times time. Okay? So initial investment of 200 bucks. All right, so that goes right here. Initial investment goes right there. E to the, they give me a rate, 6%, so 0.06. Time is unknown. How long has the money been invested, right? And then I'm going to end up with 254.25. All right, now you got to be careful with this. When you do this, you're going to have to take this out to several decimal places, okay? Because it makes a big difference with this when you do these things. So I'm going to go ahead and take to divide to start to get e to the 0.06t. I'm going to have to divide by 200 on both sides. And I get 1.27125. Okay? Now I'm back to, again, variable in the exponent spot. So I'm going to take the natural log of both sides. Natural log of both sides. And now power rule 0.06t comes to the front times the natural log of e. Yay, again, that's a 1. All right. And then this is just whatever this number turns out to be. So now, basically to finish this up, all I do is take time equals the natural log of 1.27125 over 0.06. That turns out to be right at, real close to 4 years. Let's see, does that make sense? $200, 6%, compounded continuously for 4 years. Okay, well that makes sense. 6% of 200 would be $12 initially, and then, after 4 years, 48 plus the interest on the interest. Yep, that goes. All right. So again, not a whole lot of new stuff here. The big idea is right here. Basically, that log base e of e is 1, and uh, basically ln is the notation for log base e. Okay. We'll do the quick checks in class tomorrow. Hopefully all is well, and we will talk to you later. Bye-bye.